All right, let's get started. Good morning, good afternoon, good evening. Welcome to the first Excelero webinar of 2020, in which we will learn how to leverage Elastic NVMe to eliminate GPU data bottlenecks. I have two guests for this webinar with tons of hands-on experience building scale-out storage solutions for AI, machine learning, deep learning infrastructures. Adam Yund is Senior Sales Engineer at Advanced HPC, one of our strategic partners in the space, and Joe Harlan is Solution Architect at Excelero. I'll let them introduce themselves in just a minute. I will take the first part of the webinar and I will focus on GPU opportunities and threats for AI. Next, Joe will elaborate on reference architectures and customer case studies. And Adam will drive it home and discuss how you can implement what you will learn in this webinar. We would like this webinar to be very interactive, and we would really love to get as many questions as possible from you guys. We have a lot of registrations and a good number of attendees I see, so that's awesome. How does the Q&A work? Everybody but us, the speakers, will be on mute, but at the bottom of your UI, user interface, you should see a Q&A button where you can post as many relevant questions as you want. We have a team of specialists sitting ready to answer those. And at the end of the session, I will answer the best questions we got live for the whole audience. Before I continue, Adam, as our guest, please, why don't you introduce yourself quickly?
Yeah, can you guys hear me?
Yes.
Okay, yeah, this is Adam Junt with Advanced HPC. We're a small value-added reseller out of San Diego, California, and I'll be telling you more about our company in a little bit.
Awesome. Joe?
This is Joe Harlan, coming to you live from Austin, Texas. I'm a solutions architect with Excelero. Been with the company since late 2016. Pretty excited to be here today. Thanks.
All right. Let me change slides here quickly. All right. Before we dig into GPUs and their storage challenges, I thought it would be interesting to take a look at trends and shifts in the market. One thing we've noticed is that verticals and use cases, as we've known them, are morphing and they're very much merging. Storage requirements used to vary a lot between verticals. For example, enterprise storage used to be very different from HPC storage or cloud storage, but today those differences are gradually disappearing. Use cases are deployed across verticals, and as such, requirements across verticals and use cases are becoming very similar. For example, HPC workloads, as some of you know, are getting more and more cloud requirements. And then on the other side, cloud providers need to sustain more high performance workloads than ever. So what we're seeing in the with the convergence of cloud, HPC, and AI is that there's forming what we call a high-performance data center. And as you will see when Joe talks about case studies, deep learning workloads, for example, are being deployed by supercomputer centers, startups, financial enterprises, insurance companies, even big web companies. And as a result, the other trend that we're seeing, and that is probably not news to most of you since you guys are on this webinar, is that those workloads are very data intensive. The number one requirement for the high performance data center is logically the ability to process as much data as possible in the shortest amount of time possible. So on the graphic on the left shows you the requirements or how requirements have evolved across analytic workloads over the past decades. Back in the 90s and the early 2000s, business intelligence was very hot and probably the most demanding data processing workload for which massive high performance databases, what was called high performance back then, were deployed on super expensive SANs. Later in the 2000s, we saw the whole evolution to big data. Not sure if anyone remembers the 3 V's: volume, variety, velocity. But that was peanuts compared to the amount of data that some of the current deep learning applications are processing. A huge game changer for AI and the AI workloads was the development and availability of GPU technologies. So GPUs with their many cores are perfect for parallel workloads. where CPUs are more used for more serial forms of processing. So it's probably safe to say that GPUs are the most fundamental building blocks of the AI stack. But on the storage side, there's also a big game changer, which is NVMe. NVMe Flash, which was designed to provide very high performance and very low latency, but locally. So current NVMe Flash devices can deliver over 1 million read IOPS, over 6 gigabytes per second of bandwidth, with as little as 20 microseconds of latency. So one may wonder if we really need all that horsepower. Well, our AI customers definitely do, and they typically need more than the horsepower of one NVMe device. Because the challenge is, as I said, NVMe has been designed to provide this performance locally, and GPU servers typically have very limited local storage capacity. So in essence, in many cases, GPUs can process their local storage in minutes or even seconds, which is really problematic, as GPUs would have to sit still. They would be idle while data is being copied towards local storage to process the next batch of data. So this is really a problem that we define as the GPU data bottleneck. And to solve this, we came up with a solution that is called Elastic NVMe. So before we dig into that, what are the key requirements for GPU storage? It is to share NVMe between GPU servers or to add capacity. So these are two setups that we see a lot with customers, and which Joe is going to dig into. Customers also need to be able to scale performance and capacity linearly, but without using any CPU or GPU processes for storage applications, right? So what is Elastic NVMe? Elastic NVMe is a way to provide NVMe storage in a scalable way, where GPUs can either share NVMe capacity amongst GPU servers, or where customers can decide to add a box with a lot of extra NVMe capacity, which the GPU servers can consume as if it were local storage. And our solution, NVMesh, is such an Elastic NVMe solution. Now, very high level, how does it work? You see, we have got 3 layers on this graphic. So typically, NVMesh is deployed on standard servers with NVMe devices in it. NVMesh is a software layer that will abstract the capacity of those NVMe devices and create one big pool of we call it an elastic pool of NVMe capacity. And from that pool, we will be creating logical volumes that then can be accessed either directly as block storage or with a file system, local or parallel file system by the application, by the GPUs. So to conclude my part, on the left side, you can see the storage requirements that we are getting from customers and partners. So the ability to share NVMe between GPU servers or add capacity with local performance, a minimal latency, linear scalability of performance, no usage of CPUs or GPUs, and the ability to support existing AI workflows. And then on the right side, you can see how with our unique selling points, which if you've been following us longer, these have been the unique selling points that we've been promoting from the start. Those are actually answering one-on-one exactly to the requirements of GPU storage. Now, that was, for my part, the introduction. With this, I would like to hand it over to Joe, who's going to talk to you about case studies, reference architectures, really the cool stuff, what you're here for.
Thanks, Tom. Great. So looking at these reference architectures we've laid out that we call elastic GPU storage. The one on the left, we refer to as storage expansion. If you look at many of the GPU platforms in the marketplace, and in this picture, some of you will recognize the DGX form factors, the DGX1 on the left and the DGX2 on the right, but we're not harping on the DGX in particular. Any GPU platform has limited capability to contain NVMe drives. This is largely due to their PCIe topology. So with the limited number of NVMe you can contain within one of those servers, you're really not able to feed it a data set that's large enough for the precision that customers are typically looking for in their model training. So what we're offering here is the ability to extend the connectivity out from the box using the built-in network interfaces that are available in many of these platforms to reach out to a server running NVMesh containing more NVMe, or maybe multiple servers to feed that GPU system a considerably larger amount of data than it could contain in and of itself. Looking to the right there, the shared storage option. Consider a data center with many multiple GPU systems and a nice fabric. In this scenario, we can offer several boxes containing NVMe and dramatically increase the scale of the data sets that are being processed by these systems. And by layering on file systems, you can actually do this with a single namespace and give all of them peer level access to the data. Looking in some of the customer wins and use cases that we have with our partners here, InstaDeep is a customer that leverages AI for various external organizations to enhance their business values. They started off with a DGX1 system and realized very, very quickly, like I mentioned earlier, that the limited capacity capabilities of that box weren't going to meet their requirements for data ingest. They also looked at how they might add an external array to this system. And they quickly realized the traditional controller-based architectures of those systems don't really perform as well as some of these GPU systems can ingest data. And it takes a lot of time if you're going to just try to use that internal capacity of the GPU server to copy data from those external sources. So having that data centrally located or in a position where there's a pool of storage connected to these systems, giving them the performance they need that is high enough in terms of capacity, really brought on the value. So working with one of our partners, we were able to provide them with hundreds of terabytes of external NVMe, delivering what felt like local performance through those network connections on these boxes and allowing them to reach their goals for training time. Looking at the next solution, this customer actually had multiple GPU servers working on some significantly larger data sets. In terms of data set size, millions and millions of files ranging in size between 150 and 700 KB. These are actually image files. They would ingest these files very, very rapidly. And again, having tried to do this both in the cloud and realizing that at their scale they needed to move on-prem, they initially tried some traditional storage solutions. And between having to try to copy data in and out of the GPU servers and contending with the low performance of these legacy storage stacks, they became frustrated and engaged our partner, Advanced HPC. Through working with Advanced HPC, we were able to deliver a solution with NVMesh powering a BGFS file system, providing an elastic pool of file storage with extreme NVMe performance to these servers, dramatically reducing their training times by 3 to 4x. This is really exciting for them. They're able to get a whole lot more work done. They're even looking at increasing the size of their data sets to increase the precision of their model training. So very, 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 very capable use case here. Then we have the Science and Technology Facilities Council. This is a United Kingdom government agency that specializes in science and engineering research. They acquired a couple of DGX2s for some deep learning training, and they realized really quickly, again, that these systems can only hold about, a couple double-digit terabytes in capacity, but many of their data sets were, 200 plus terabytes in size or larger. So looking at a few scenarios, they went back and forth between a few traditional array technologies, again, trying to manage this idea of copying data up and down in and out of the systems, and realized very quickly that the data pipeline was being dramatically hindered and their training times were being elongated as a result. So they put out an RFP, and working with one of our partners, they were able to implement the solution you see there on the right. So again, a BGFS file system powered by NVMesh beneath, running on the Boston Talon servers. They are 2U 4-node servers with 24 NVMe, very powerful systems, and you'll see something very similar to that here in a few. Again, they were able to really dramatically increase the efficiency of their data pipeline, reduce their training times, and deliver value much, much faster. Here we have an anonymous financial services organization. This one's really interesting. So they started out trying to do credit card fraud detection. And as you could probably guess, detection is a little late. So once you've already been compromised, you've already lost customer money and your own money. So this could be a real problem. And they realized very quickly that in order to do fraud prevention, they would need to move into an AI just-in-time model and be able to assess the risk of a transaction as it's in flight. In order to do this, they started out with a few GPU servers, connected to some storage, and quickly realized, okay, we're not getting what we need. What can we do? Through some of our partners, they engaged us, and we were able to deliver a solution to them that reduced their training time from 3 days to 45 minutes in terms of adjusting their model. And if you look there on the right-hand side, you can see the solution deployed at scale. Essentially, what they've done here is they've taken what is generally a static, very large data set, and they've made it available to each of their GPU servers in read-only form, using the highest performance level of the storage, which is the block layer. It's the leanest. So with just a local file system on each of the volumes containing the same data set, they're able to attach that volume to each and every one of their GPU servers and do their model training very, very rapidly and at an extreme scale. So being able to get this model adjusted on a frequent basis, they simply need to update the data set and reattach the updated set to each of the nodes and begin the retraining phase. When it only takes 45 minutes to train, this allows them to iterate over multiple models and attempt to increase their precision very, very rapidly, and gives them a lot of value. And with that, I'll hand it off to Adam at Advanced HPC to describe some of their solutions.
All right, thanks, Joe. So here at Advanced HPC, like I said, we're based out of San Diego, California. We've been in business for over 10 years. And we're always on the lookout for what's the next big thing in computing or storage. And that's actually how we got in touch with Excelero. We had an account that had a lot of GPU-based systems, and they said, hey, we need like an NVMe over Fabric solution. What do you guys suggest? And that brought us searching through, and we found Excelero, and they bought into it, and they've been really happy with it. So if you've never worked with a value-added reseller before, we have a few benefits over working with a traditional shop like Dell or HP. One is that we're connected to a million different companies, maybe not a million, but probably 50 to 100. And here's some of the highlights that I've listed there. So let's say you want a Dell-based system with NVMe, yada, yada, yada. Cool, we can provide that. Let's say Dell has a long lead time though. Okay, now we can go to Supermicro or Asus or another provider. And that goes through every component that is within that system. So let's say Micron NVMe drives are not available. Well, we have the ability to go get a Seagate or an Intel NVMe drive and also support those. So that's the benefit of working with us, is that we are connected to a ton of companies. We can provide pretty much anything that goes into your data center. And we've been in business for a while. And because we've been in business for 10 plus years, you know, we've made contacts with everybody within those businesses. So let's say there's a problem with your Dell-based system, and for whatever reason, Dell support is being really slow and painful to get back to you. We know the top 10 people at Dell to go to for support and get you an answer a lot faster that way. So that's a great part of doing business with us. See if I can advance to the next slide. There we go. So when we have our customers contact us for GPU-based systems for AI and HPC workloads, we're in a unique position that we've done business with thousands of customers, and we know what they're using. That informs us. We're in contact with all these with all our partners. We know what they recommend as well, and we have consultants that we go to. And some of the big problems that we face is, hey, number one that we face in AI is what kind of GPU should I get? What kind of CPU should I get? And so we can talk to you about your workload, what you're actually running. If it's not AI, and let's say it's cryo-EM or some other molecular dynamics type code, we can talk through that. But if you're using GPUs, we've been seeing more and more customers come to us and say, hey, we're not feeding our GPUs data fast enough. We have this, a lot of our customers want to put on a single NVMe drive, but as Joe mentioned before, that time that you just transfer data over to that NVMe drive is just time wasted. And maybe you don't have enough storage actually for on that one drive for the large data set that you want to run. So where does that leave you? So these are some of the problems that we've had. And another big thing is a lot of our customers are in the EDU space. And when they write these proposals, they're only putting in money for GPU systems. And they think, hey, I can't afford a flash tier. Those are too expensive. Luckily, that's not the case with Excelero. When I show them the numbers, and we'll show you an example of bill of materials after this slide, I believe, they say, is that per year? And that's actually a 5-year cost for the system. So we can actually do some great things with this technology at an affordable price, which helps everybody out. All around, the customers are looking for, like Joe and Thomas said, it needs to have high IOPS, high throughput, and low latency. And that's exactly what NVMe provides. You can't do that just on node, though. After a certain point, let's say you added two 15 terabyte NVMe drives on your DGX1 or your Supermicro equivalent version of it. That's great, except until you pass that 30 terabyte mark. And if you want to have, more importantly, we did a build out for Clemson at one point. And it was BGFS with NVMe. And it works great for performance, but then they have no data protection. So what they had to do is they lose half of their capacity to do a mirror of it. Whereas if we would have gone with Excelero, we'd actually get a lot of that capacity back. And we're actually talking with Clemson about this. So we are looking at some options for them. And that's what the benefit of working with Excelero provides is you get a lot more capacity, much better value, great performance. And this is what they're good for. And also their expertise in the area too. Okay, can you go ahead and go to the next slide as well? Okay, so here's some of the example turnkey solutions that we do provide. These are with Supermicro chassis. Like I said, we are partnered with HP, Dell, Asus, Cayenne, Gigabyte. So if you have a preferred manufacturer, we can definitely work with you there. But for like a base entry, we could look at the storage expansion on the left. And that's just a single node. And it's capable of doing around 11 gigabytes per second. And that's with only 4 NVMe drives in there at only $23,500, right? So really low cost. What more could you ask for on that? And then over on the right, this is the 2U quad node. This is what we've done at quite a few of our customer sites, actually. This is an all-in-one solution. So this can kind of sit at the top of the rack and feed down to all your storage. And this is fully HA, 245 terabytes of NVMe. So a much bigger solution, still at less than $100,000. So for our customers who say, hey, I have a proposal for $500,000 to buy all these DGX systems, we say, hey, don't forget to actually take full advantage of those. You want to look at something like Excelero, and here's the low price point. So you're still getting all your GPU systems, but you're also getting storage to actually take advantage of it and get the full potential. Okay.
All right. Thank you so much, Adam. Let me stop the sharing here for a second so I can get into the questions for you all. Am I still with you guys? Yeah, so folks, feel free to post your questions. At the bottom of the UI, you should see a Q&A. I'll give it a second. All right, I'm getting a first question here from John. This one is probably for Adam. Adam, What GPU-based systems have customers mostly been purchasing?
Yeah, so we've seen a lot of, first of all, am I off mute?
Yes, you're good.
Okay, good. Yeah, we've seen a lot of customers purchasing, they're usually like Supermicro systems with 8 GPUs in them, PCIe based, and most of our customers are putting in 2080 Ti's. I'm sure NVIDIA doesn't want to hear that. Hopefully they're not on the call right now, but that is a big part of what our customers have been purchasing. I'd say the second most popular system is the DGX clone. So Supermicro produces a system that is SMX2 connected, and the benefit of using that over the DGX is that you don't have to pay the NVIDIA support costs or get their all their software that they put on there, and then they say, hey, you're not allowed to change this. So for our customers who just say, hey, we know the software we're going to put on this. We don't use the DGX software. We put our own stuff on here. I don't need that extra cost. Let's save $10,000, $20,000, $30,000 instead. That's an option they're looking at. So those are our two big solutions that we've been providing over the past couple of years.
All right, thank you. That was very helpful. The next question I got from Don. What have other customers been using for low-cost backup storage?
I'm guessing that one's for me as well?
Yeah.
Okay, yeah, we've seen customers who do already have, let's say we sell them Excelero, and so they have their flash tier. We do have some customers that just want a cheap JBOD off to the side, and you can get a 720 terabyte JBOD now for less than $20,000. So you can build out with small NAS for that, depending on how much storage. You can do BGFS as well for that. We are the #1 BGFS solution provider, and that allows us to provide a low-cost, scale-out solution, and on top of that, provide all the support you need for it. So there are some low-cost backup solutions and mid-tier options available for you based on that.
Okay. Thank you. Next one, I'm gonna let you guys fight over who takes this one. What makes this solution, this comes from Diane, what makes the solution different than other solutions that are being promoted left and right, and what makes your file system better? Joe, maybe you want to take it?
Sure, no problem. So really what makes our solution different is its elastic ability to scale and do so linearly and maintain the performance and low latency characteristics of the media. There are many options out there for employing NVMe to your data problems. Few of them are able to scale at the rates we're able to, and none of them are able to maintain the low latency characteristics of the media as efficiently as we are. From a file system perspective, really we offer open choice. So you saw in the presentation we discussed a couple of customers using BGFS, but that's not really the only file system available out there. Several others exist, and at a block layer, we're really agnostic to the file system and able to support all of them.
All right, thank you. That one's for you as well, Joe, from Belinda. How are we notified from Excelero if a drive goes bad, and how do we recover?
Sure. So Excelero has a management solution, of course. So in the management plane, a customer can interact with the web UI or the CLI, or receive alerts through their monitoring harness, whatever's part of their data center operations, that a drive has failed. Once they've been alerted that the drive has failed, depending on how they've created things, that any volumes impacted by that drive failure should rebuild, and they'll be able to replace that drive or retire it completely as they see fit.
Okay, thank you. And a follow-up question I got is, how do you provide HA on the server level?
Sure. So we're actually not providing HA at the server level. We're providing HA for the volumes that are created. So as you create volumes, you declare their volume layout. And we allow you to do this arbitrarily. So media is not pinned to one layout type or another. So you could have a mix and match of all the various logical volume layouts that we support, protected or unprotected or otherwise, across the same sets of media. to support different use cases within the workflow. In terms of availability for the mirroring or the erasure-coded volumes, we also enable the protection of node fault, so node fault tolerance. With the mirrored volumes, the halves of the mirror are always strictly separated across the systems. Or you could choose to concede that and do the mirroring within a system, depending on the scale of the solution you've deployed. And the same story goes with the erasure-coded volumes. For example, with an 8+2 erasure-coded volume, if you had 10 servers with one piece of media in each, then you could suffer up to 2 node failures without reducing the availability of that volume. So the data can continue to flow for all of the running applications.
Great, thank you. Sarah is asking which NVMe drives are supported?
It's a great question. So we actually publish a hardware compatibility list. We can share that with you if you're interested. Essentially, we partner with all the major drive manufacturers. We take engineering samples and we qualify those drives, and then they're posted to our compatibility list. But in large part, there's fewer drives that we don't support than there are that we do. So just ask a question if you have any concerns.
All right. Getting a few more questions here. I'm looking for what is most interesting here. How does the system scale? How do you add more capacity?
Sure. So adding more capacity is as easy as populating empty drive slots on the existing storage nodes that you own, if you have empty nodes, drive slots, or you just simply add additional systems. There's no hard and fast requirement suggesting that they have to be identical systems or identical drives. We support a mix of NVMe make model within the same cluster as well as within the same node. So if you needed to buy read-intensive or write-intensive drives for 2 different aspects of the use case and populate those in the same systems across the fleet of storage targets you're deploying, that's absolutely doable. And then with the powerful templating engine that we call volume provisioning groups within the management plane, you can define how those volumes are to be created across that media. So very flexible capability there in terms of managing the fleet of resources.
All right. I have 2 more questions here. So folks, if you have more questions, please go ahead right now. Otherwise, these are going to be the last questions. What's the difference, question from Paul, what's the difference between NVMesh and NVMe over Fabrics?
Sure. So NVMesh versus NVMe over Fabrics is really sort of a nuance. So NVMe over Fabrics being sort of the open source side, with that capability, you really have something analogous to the iSCSI protocol itself. It's very basic in terms of point-to-point connectivity. At its inception, initially, it was meant to export access to a single NVMe drive, or maybe an MD RAID volume created from a series of drives within a single system. With NVMesh, we actually extend upon those capabilities in terms of being able to allocate that shared resource to more than one system at a time, enabling shared parallel file system access, for example, IBM Spectrum Scale GPFS. Additionally, the solution is more of the NVMesh solution is more of a complete solution. It's an entire software-defined stack. With NVMe over Fabrics, it's a transport. That's really all it is. Someone would have to take that and build around it in order to make it fully functional. In a near-term future release, we're actually going to support the use of NVMe over Fabrics, the open source feature, alongside as part of and managed by the NVMesh solution. So that should alleviate the concerns for being able to run NVMesh in certain places or not being able to run it in other places. In the case where you can run the NVMe over Fabrics component more easily or readily, depending on your data center policy, of course.
Awesome, thank you so much. And I'm getting a follow-up on the NVMe drives that are supported. Phil is asking whether we recommend a specific type of NVMe drive for GPU workloads. And oops, it was disappearing. For example, when it's really, GPU-driven workloads tend to be very read-intensive versus mixed-use NVMe devices. So what's your recommendation with respect to the type of drives?
Sure, some of that's going to come down to a cost model and aligning that with the workflow, right? So if the data pipeline does include a significant amount of write activity that needs to be timely in its execution, then you probably want to go with a mixed use or a write intensive drive. But to your point, Tom, if it's a largely read intensive job, which many of the training models are, and if the data set that the models are being trained with don't change frequently, then certainly a lower cost read efficient drive or read intensive drive is going to be the better option.
All right, perfect. And then the last question I have here is, does NVMesh support Ethernet, RDMA, or just InfiniBand for networking?
Happily, we support both. So RDMA over Converged Ethernet version 2, often referred to as routed Rocky, is the Ethernet variety of the InfiniBand transport and the capability to use RDMA.
Okay, perfect. I have no more questions, so all that's left to do is I'm going to reshare my screen for a second to promote our next upcoming webinar. There are not a lot of live events these days, so we're switching fully online. On the 30th of March, we're going to have our CEO, Lior Gal, to share his 2020 storage State of the Union. This is going to be really interesting. Lior has over 15 years of experience in the storage industry, selling into HPC and web scale customers. I really recommend to tune in for this one. And yes, the recording will be shared. I'm seeing 2 more questions. We will take those offline, Oscar and Oguzhan, because we're running out of time. I would like to thank Adam in the first place. Adam, thank you so much. This was really very helpful. Joe, you as well for your time. And then especially everybody who was online. Thank you so much for making this such a big success. This was a really big group. We cannot see it, but it was a big group. Very happy about that. Thank you so much. Have a great rest of your evening, afternoon, or day in case you're in the US. Be safe and healthy. And I hope to see you guys 2 weeks from now, March 30th. Thank you, everybody. Bye-bye.